Welcome to a new test and teardown video. Yes, another oscilloscope. This one is a Tektronix 465. The 465 is probably the most successful Tektronix scope ever. And it's a 100 megahertz oscilloscope, dual channel with dual time base, and a lot of super cool features. It is packed with features and buttons, and everything here is doing multiple things, and it's just a fantastic oscilloscope. Really good. And this one is in mint condition. You see all the text and stuff, and nothing here is destroyed, so that is really good. I look so much forward to see if it works or not. And this is really old, by the way. This model was introduced in 1972, and this was succeeded by the B model. See, this is the 465, so there is no B, so that means this is before 1980. There are many different versions of this one, so that is something we can maybe see on the PCBs. There will be a number for the version. I think this is the third or the fourth I got of this model, and this is by far the most beautiful one. So that is super good. I also got the plastic cover. Well, let me show you the top plastic cover here. It is completely intact as well. See, even with all the operating instructions. How about that? So yeah, I got the top cover in super good conditions as well, and look at that. Let me hold it here with my feet so it's not gonna fall. Hang on. This is better, right? Let's look in here, because you know what? I already did take a little sneak peek. I got 2 original probes. What is the chance of that? And normally you should inspect this point here of the wire, and you can see it is a little bit bent, but it's not crusty or bad in any way, so I expect the probes will work. Oh yeah, about the probes, look at this little springy feature here. This connects to this outer ring on the BNC, and it controls the lamp here, because you can see here. So this is the highest voltage, 5 volt per division. This is of course what the scope is doing natively, but of course this is a ×10 probe. So when I connect this ring to this one, the lamp moves from 5 volts to 50 volts per division. So again, you know what you're doing. This also shows you that if you got a very low voltage level, of course you can't use a ×10 probe on very low millivolts, because you got 50 millivolts per division with a ×10 probe. Also, what you find in the goodie bag is this. Of course, an extra ground lead for the probe, but what is that? That is an extra glass for the screen. So all the scratches and stuff you see here, this is a brand new screen. What kind of luck is that? So let's see if this thing works, shall we? Let's look a little bit on the rear, but I just wanted to show you guys on the side first. This is the voltage selector, right? It says 230, so that is good, but it's located on the side. That is a little bit funny. The rear side here, we see 4 B and C's. External C, vertical 1 signal out, B gate and A gate. But what is that? Line fuse inside, low, mid, high. I want to see what is in this one. This is a little bit weird. And yeah, there's a fan. Okay. I think I got it. So the switch on the side is the kind of main range, 115 to 130. But then again, you have a fine tune. Look at that. So if you are in this range, 198 to 242, or are you in the medium range, or are you in the high range? How is that going to work? So that means I should actually move this to the medium range. I think so. Yes, low, that is, then I'm overloading it, right? So yeah, I need to move this and then move it one step up. That is cute. I've never seen anything like this before. And then the fuse is located here. So when you pull this out, you remove power. And you can't stick your fingers in here. So you can't get electric shock. I mean, that is really nice. Tektronix. Really, really nice. Okay, it says 75 watts. That is good to know. I really like to check this every time I power up some really old funny stuff. Know what kind of power it uses, what to expect. So I am ready to power it up. I gave it 230 volts and we need to pull. I see light and I see a lot of. Okay, that is channel 2. Alternating. Chop. That is good. Focus. Okay, intensity is like intense. Okay. I mean, what kind of lock is that? We got smooth position and stable. That is a little bit weird that I see those jumps on the other channel. You see, this is just mechanical. Yeah. Beam finder. Yeah, that is good. Now I will go through all the different features and see if it works. It looks normal with all that stuff. And yep. Oh yeah, by the way, there's a funny feature here. Low line voltage. Let's try and see if that works. Okay, let's turn off the light here. Let's turn down the intensity. So we should be able to see this lamp. That means now I'm going to crank down the supply voltage and see if this is going to go on. Yeah, look at that. Wait, it's blinking. But the scope is still performing completely normal. Yep, and the voltage is 196, 195. So at 195, we get this low line blink. Ha! That is great. So that works too. And this is 51 watts. And if I crank up the voltage to 230, it is using 62 almost. So far so good. Wow. It is amazingly powerful. Holy moly. Even that works. And those are really bright. It's almost too bright looking at those lamps. They really hurt my eyes actually. Let's try and see if the probe detector. Oh yeah. So that works too. I mean, this is definitely one of the better days. So I'm going to play a little bit and I will continue. Yeah, let's play a little bit with this scope. So this is the normal mode. I am in alternating mode. I can also be in chop mode so you can see the difference. I don't think you can see the difference anyway here. So let's go to mix mode. So that is the dual time base. And what I did is I pulled out the time base knob. And then, see, then I can adjust. Or I can take the finger in here and I can move this part. Isn't that fantastic? And the way that this works is that we've got actually another trigger. Let me see if I can zoom out a little bit so we can see the entire scope. So there's another trigger here. This is the delay trigger. See? So if it is a trick here, that means the delay here will search for the next trick point, see? So that is actually really, really nice. And then I can be in mixed mode, so I both see the original and the zoom. I can also do it like this, so I can see where I am. Or I can only show the zoomed here. You can't see any difference because this is just repeating. This signal is of course just the same and the same all over the place, right? So mixers also a very good way to show you guys something. And you can imagine the speed change here. This is, by the way, a 100 kilohertz signal, and there's still plenty of brightness. So this is the funny thing here. So it automatically adds extra time or brightness time, as you can see, to this portion, because it will expect you to zoom in, right? And then of course you end up getting more brightness depending on how you adjust this. Yeah, absolutely fantastic. Yeah, all that stuff works as well. Let's check the bandwidth. So here's what I'm doing. This is a 100% signal, and you see the dotted lines. Maybe I am actually a little bit under here. So let's just be a little bit friendly today and give it in the middle of the dots. Oh, that is way too much. So this is a 1 kilohertz signal, and so we're gonna crank it up. What is that? That is 10. Dip, dip, dip. And let's crank it up to 100. One megahertz. We don't see anything yet. 10 megahertz. Oops, that's all the way. So that was 10 megahertz. Oh, and it starts to decrease a little bit. So what we aim for now is that line. Oops, we have a trigger issue. This is 120 megahertz, by the way. And let's move the position a little bit. So 130 megahertz. 130 megahertz is the bandwidth of this scope that is, what, 45 years old. And let's play a little bit. Yeah, I am actually really happy about this. And there's also a nice indicator here. So all those indicators, they work. Yeah, also that one. All the lamps works. So far I was not able to find anything wrong with this machine. That is one lucky day. So now we're inside. This is the bottom PCB. It is just perfect. So beautiful. There's a nice big warning here about high voltage, and there's probably even more in here. Minus 2400, but I think it is 18 kilovolts in total on this thing. So this will be horizontal deflection. You can also see the two sets of transistors here handling the horizontal. And if we look really careful in this hole, we'll see a reel of cable that is spooled up in here. That is the vertical delay line. So there's a balanced cable in this coax. It's a very special coax, and wires in here, they are wounded up to create a much longer delay. So this is why we can actually grab the first edge of a signal we are triggering on due to this delay line. I don't know if we can get a better view of that. I think we need to dismantle the entire thing to get in here. Oops, what is that? I heard a loose part falling down. That is not a good sign, and I need to look into that. That will be the two input channels. There's this large board here on the side. No, it's not. That is wrong. That would be the external tricks. So that is me saying a lot of wrong stuff. This is the main power input. I really love the way they solved this. There's actually even room for another switch if you want to have two of them. That is so beautiful. And the transformer is located actually quite close to the CRT, but behind a wall, and the CRT is of course completely sealed into some very good magnetic shielding, tested by Tektronix, and somebody signed this. Isn't that just beautiful? I think I forgot to show you guys. Many of the transistors, they're actually in sockets. So you could easily replace the transistors. But some are not. For some reason. No, look at that. They're still in sockets, but the sockets, they're built into the PCB or something like that. Wow, that is nice. Ooh, look at those diodes, really cute. I think it actually say Tektronix or something like that. Yes, it does indeed. On the ICs. Ooh, that is beautiful. And that is the time base. Some more power supply parts. Oh, look at the delay line. That is a big one. I'm not going to dismantle this and get down there and figure out how long that is, but that is definitely a very, very long cable. And if we look here at the end, so this will be the vertical, as you can see, the two input channels with all the good trimmers for high speed and stuff. Ooh, and again, all the matched transistors. Ooh, yeah. I'm just checking for temperatures here. It's not that bad. I was a little bit worried about the way they look. I want them to be all the way. That one was a little bit long, far out. So that will be the vertical amplifier. And of course, if you look real careful, you should be able to see two wires going into this coax. It's because this is a special balanced coax cable for this delay line, and the other end of this cable probably go directly to the deflection, or it can actually in some scopes come back somewhere else in the amplifier, and then the scope is driven directly by the deflection transistors. I don't know exactly yet how it is done in this one. It is just a matter of following. Yeah, look at that. Here we go. That is the other end of the delay line. And then we got the deflection board driving the deflection plates as you see them here. So that is how it's done in this one. And of course, this is good for high speed, because this thing handles 100 megahertz. It's also saying here 1971 is the design of this deflection board, and this is a 07 revision of this board. Some of those boards, or some of the changes, they are listed as 37 different changes performed. And so, I mean, if we look at this board, it's probably going to have another version that is not written here. So that will be the vertical preamp. Blah, 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 blah. Maybe it is, yeah, see, that is 09. Here we go. That is a super beautiful scope. An extra shielded case around here. This is massive. And of course, this is how it is with magnetic shielding. You need a little bit of thickness and a little bit of material for this to work real good. And this is what they save in other scopes to make it cheap and lightweight. Oh, look at that. This is the fan. Look at that fan motor. How nice is that? And all this electronics here is what it takes to run this fan. What do you know? So there's an IC from 1972 driving the fan. That is something. And that is just the power supply cables for the fan, and that's all there is to it. Oh yeah, and here. What is that? Where's that going? Yep. Here we go. So this is the trick view, or 20 megahertz bandwidth. So we got two functions in one arm here, and of course it is in the vertical stage where you just limit the frequency or the bandwidth by modifying some of the components right here. See, this switches directly into the PCB. I mean, look at that. For high speed and all good things from heaven. Great, great design. It also says here on the PCB, this is the bandwidth limit. Yeah, I'm sorry this is going to be a very boring video because there's nothing wrong with this scope, so I can't really poke around and change components or look for bugs or anything because it's just absolutely perfectly good. So I can show you the... Yeah, I can't really show you this. I don't think we can see. Yeah, we can actually see the attenuator here. The voltage range is done on this piece of this PCB here. And then this is the variable. Oh, mechanical details. This is just so nice. And then there's this little click, and then it lights up the little bulbs in here. I hope you're never going to replace the bulbs in there, because then you need to pull the entire front to pieces to get in there, by the way. And caution, better look up the manual before you punk around in here. I've been looking a little bit here on the CRT and power supply board, and what I find is a 73 date code on those op amps. So I think this is the newest parts I could find in this unit. Also, when it comes to revisions on PCBs, so there's a revision of the PCB layout. This is revision 6, but then there's also a revision on the mounting or component mounting as well. And this should be written here, but it is not. So maybe it is that stamp you see here, a PCB mounting revision on top of the PCB design number. But of course there will be Tektronix experts capable of commenting on that. So this, please do that then. So this is the 1971 base design, or first revision design, and they actually kept this 71 on all things. But of course this one is a little bit newer than that. And what have you got here? I don't know if you can see this mark. There's a nasty mark around this, like a knife. Look at that. So something really sharp made a mark right next to a capacitor. Why would you do that? Somebody dropped something sharp here. Anyway, I think this is what I wanted to show you guys. I hope you enjoyed the view. Please come again tomorrow. So here is my classic 1 microsecond pulse, and the repeat rate is 100 kilohertz. So look how well the delay line works in this scope. See, I even get all this before the start of my pulse. Isn't that just amazing? So it is actually way too long, this delay line. I am now in 200 nanoseconds per division. So this is exactly 1 microsecond. Look how accurate that is. And this is, 1 nanosecond rise time. Let me show you guys what happens if I give it like 20 nanoseconds rise time. I'm playing with the rise time here. I'm not playing with the fall time. So that is unchanged, by the way. So let's see how fast this is in the fastest. I can't see that, can I? So that was, 200, 50 nanoseconds per division. And how about I crank this up? Where is it? Here it is. So that is 5 nanoseconds per division, and I still got plenty of brightness. 5 nanoseconds. Right, and let me see. Okay, 2, 3, 4, 5 is my rise time here in this case. So it should be about 1 division from 10 to 90%. So even that is accurate and still working. Let me try and do 10 just for the fun of it, right? So that also works and is super duper accurate.